Section 9.2.36, the trade volume of a stock is the number of shares traded on a given day. The data in the first accompanying table in millions, so that 4.78 represents 4,780,000 shares traded, represent the volume of a certain stock traded for a random sample of 40 trading days in a certain year. Now, a second random sample here on the right of the 40 days in the same year resulted in the data in the second accompanying table. We want to complete parts A through D. So for part A, it's asking us to use the data from the first sample to compute a point estimate for the population mean number of shares traded per day in the year. So remember that the sample, or the point estimate, is the sample mean. So we want to find the sample mean. So what we're going to do is we're going to open up this in StatCrunch. So we're going to click here to open up that table. So over here, we're going to open up in StatCrunch. Okay, so now that we've opened it up in StatCrunch, now we want to find the mean of this information. So we're going to take the column, and then in addition to finding a mean, let's find a standard deviation as well. So we'll go ahead and do that. So now we have the mean and the standard deviation. So if we look at the mean here, the mean is going to be 4.379. And so therefore, we're going to say that a point estimate for the population mean sample of shares traded per day for sample 1 is 4.379 million. Okay, now in part B, what they want us to do is use the data from this first sample to construct a 95% confidence interval for the population mean number of shares traded per day in this certain year, and then interpret the confidence interval. So let's write down the given information that we know. Well, we know that the sample mean is equal to 4.379. Okay, we also know what the sample standard deviation is because we brought that in here. So let's round that to 4 decimal places, and that's going to be 2.3567. We know that the sample size, well, they're giving us here, it says that there are 40 days, so we know that n is equal to 40. Okay, and then what we need to do is we need to find that critical value. Okay, so again, we have a 95% confidence interval, so in order to find alpha, it's going to be 100% minus the 95%, which gives us 5, and we know that gives us 0.05. And then if we want to find the critical value, we're going to take that 0.05 and divide that by 2. So we're looking for the area to the right in a tail that is 0.025. Okay, so if we wanted to use INVT, so we know that our area is going to be 1 minus 0.025 because that is the area to the left, and we know that the degrees of freedom is going to be the following. Well, the degrees of freedom is going to be 40 minus 1, which is equal to 39. So now we're going to use 39 here. Okay, so let's go ahead and do that. So in our calculator, we're going to go to second distribution, INVT. We're going to put in that 1 minus 0.025, which is already in there. And then we're going to put in 39 for our degrees of freedom. And select paste, and then hit enter. And so therefore, that's going to give us our critical T value. Okay, so let's round that to 2 decimal places, so that is 2.02. If we want to do that on StatCrunch, then we would go to Calculators, and then go to T. And then we're going to put in degrees of freedom, which is 39. We know that we want the area, we want it to be greater than the area of 0.025 so that we can compute what that critical value is. So we get the same one, which is 2.022. Now, if we put in the area to the left, okay, which is 0.975, then we'd have to make sure that this says less than or equal to give us the positive critical T value. Okay, So now that we have our critical value of 2.02, you can also use the table as we've done in previous exercises. So now what we're going to do is we're going to use the formula to be able to find the confidence interval. So here's our formula. We know that our lower bound is going to be our mean, our sample mean, which is 4.379. And we're going to subtract the critical value of 2.02 and multiply it by the standard deviation, or the sample standard deviation, of 2.3567. And then we're going to divide that by the square root of the sample size, which is 40. So the lower bound, we're going to round that to approximately 3.626. Okay, likewise, we want to find the upper bound. It's going to be, again, the sample mean, which is 4.379, minus the critical value of 2.02 times the sample standard deviation of 2.3567, divided by the square root of the sample size, which is 40. So therefore, the upper bound is going to be 5.132. So from here, we can interpret the confidence interval by saying, using the data from the first sample, a 95% confidence interval for the population mean number of shares traded per day in the certain year has a lower bound of 3.626 million and an upper bound of 5.132 million. Okay, now we're going to use the data from the second sample to construct another 95% confidence interval for the population mean of the shares traded per day in the year, and then we're going to interpret the confidence interval there. So let's open the second sample here. So we're going to open that up, and then we're going to open that up in StatCrunch. Okay, so now that we have that open, we're going to go ahead and we want to first be able to find the summary stats. So we're going to go to columns, okay, and then we're going to find the mean and the standard deviation. So let's go ahead and do that. We're going to find the mean and the standard deviation. So now we can say that the mean is going to equal, rounding it to 3 decimal places, is 5.565. We know that our sample standard deviation, rounding it to 4 decimal places, is 4.3975. We know that our sample size is 40. And what is the critical value? Well, the critical value is going to be the same up here because it's the same sample size. So we know that our critical value is going to be 2.02. And so now we can use this formula to find the confidence interval. Okay, so if we look for the lower bound, we know it's going to be our mean, our sample mean, 5.565. We're going to subtract the critical t value and multiply it by the sample standard deviation. And then divide that by the square root of the sample size. And so when you do that on your calculator, you're going to get approximately 4.160 rounded to 3 decimal places. Okay, then we want to find the upper bound. So we're going to take, again, the sample mean, 5.65, and then add 2.02 and multiply that by the sample standard deviation, divided by the square root of the sample size of 40. So we get the upper bound to be 6.970. So we're going to summarize here. So using the data from the second sample, a 95% confidence interval for the population mean number of shares traded per day in a certain year has a lower bound of 4.160 million and an upper bound of 6.970 million. Okay, now in part D it says, explain why the confidence intervals obtained in parts B and C are different. Well, they are different because of variation in sampling. The samples have different means and standard deviations that lead to different confidence intervals.